Alrighty, so we have a slight problem, and I can demonstrate that by hitting the play button and coming up to one of these platforms. And while the platform is moving over to my direction, so while this platform is moving to the left, if I jump into it, you'll notice I kind of get stuck in it, sort of. There's a little bit of pushback, but mostly I just go right through it. Now, the reason that's happening is we're not handling the case in which the geometry of the level is moving. Now you might be wondering, well, isn't that what, Unity's physics engine is supposed to do for us in the first place? And yeah, that's true. But again, there's a variety of reasons why we don't want to use the physics engine in the first place. We don't want to work around all the potential issues that we might have with it. So we need to come up with a very basic solution, simpler the better, that allows us to not be able to move into a moving platform. Again, this bug is only present when there's a piece of level geometry that's moving that we can jump into. But since we're going to have moving platforms, I kind of want to prevent this from happening. So basically what's going on is this. Let's go ahead and fire up Photoshop, and I'm going to diagram out exactly what is causing that to happen. Well, actually, I can explain very easily what's causing that to happen. We don't have any code in place that handles that possibility. Now the possibility is going to be we have a player, right? We have a player, and I'm going to represent the player as a rectangle because that's geometrically what he's being represented as in our character controller. And then if I have a platform, which I'm actually going to do this on another layer, if I have a platform, well, I can also use another color. Let's get fancy with our colors here. If I have a platform, this red guy, and this platform moves into the player like that, what happens is the player doesn't get any opportunity to handle this case. So the platform can simply move into the player and pass right through it. If the player is moving, however, the player will have raycast being shot out underneath his skin. So what do I mean by that? Well, remember how we have that skin on our player, where our horizontal raycasts are shooting out like that, where you can kind of see they're not shooting out directly outside of the player's volume, they're shooting slightly inside of it. Well, the reason why we get that behavior where the player kind of sort of gets pushed back just a little bit when he's moving to the right and the platform is moving to the left is that when the platform it gets into the player, then the skin kind of takes over and sort of pushes it back, but it doesn't push it back with enough force for the player to be pushed away from the platform. It doesn't repel the player with enough force to overcome the movement of the platform itself. So there's actually a couple ways we can solve this, but the simplest and easiest one to understand, I think, is going to be adding in some additional raycasts. So we don't want to go too crazy with the amount of raycasts that we're doing. Raycasts aren't as expensive as most people think they are, but we definitely want to avoid as many as possible. That being said, in this particular game, the amount of character controllers in play isn't going to be very substantial. Even if we had like 20 or 30 objects, we could achieve decent, good enough, well, in fact, good performance, maybe by just reducing the amount of casts that are done on certain objects. So maybe have the player continue with his 8 horizontal and 4 vertical raycasts, and then maybe have like AI enemies have fewer raycasts per enemies, something like that. What I'm saying is that this solution isn't going to cause any sort of massive performance penalty, and it's very simple to understand and implement. And obviously, being simple to understand and simple to implement are qualities that we strive for when coming up with solutions. So the solution is to chop the player in half. So I'm going to go ahead and add a line in here. And on the right hand side of the player, I want to create raycasts. Let's use a different color than that. Use that. I want to shoot a raycast from the center of the player to the edge of the player. Okay? So we're going to be shooting these raycasts. You'll notice something a little bit different than what the raycast that we're shooting out from the skin. First of all, I will not be shooting out a raycast on the top, and I will not be shooting a raycast out on the bottom. The reason for that should become apparent shortly here, but it's due to the fact that these raycasts, in certain circumstances where you combine vertical movement with a moving platform and a jump, these raycasts, if I were to do them, would push the player, like just fling the player to the other side of the platform if he tried to jump near it. So we're not going to be shooting at raycasts from the top or the bottom, but we will be shooting at raycasts in the middle. And we're going to be shooting them out both to the right, and we're going to be shooting them out to the left. I chose different color. Actually, with compression, those probably look like the same color. So I'm going to go ahead and choose an even more different color here, so that we can see that we are going to be shooting out.
I like more different colors.
Yes, more different colors are good. Okay, so we can see that we're shooting out a raycast to the right X amount of times, where X is the amount that we normally shoot out subtracted by 2. And we also shoot out the same amount of raycasts from the left, from the center of the player. So what's going to happen, we'll constantly be shooting these out every frame. What's going to happen is if we get a frame like this, which this can happen, this is a legal thing that could happen because we are moving this platform inside of our update method by just modifying its transform. So it is possible for the platform to come inside the player. The question is how do we correct that? What do we do to fix that problem? Well, if this happens, then one of these raycasts will, or all of them in fact, will get hit and register a collision. And what happens in that case is, so let's say what I'm going to do is I'm going to go ahead and remove all the raycasts here, and we're just going to focus on one. So maybe I'm just going to copy this so we'll have that as a reference later, and then I'm just going to erase all the stuff inside of him so that we can just focus on what happens when one of the raycasts hits the edge of an object. In addition, to make this example a little bit more clear, I'm going to completely delete this layer and redo it with straight lines. Maybe do bigger straight lines. And then we're going to move, I just drew on the wrong layer. There we go. Obviously this is not a Photoshop VTM. Okay, so we're gonna move that in, and now we're gonna talk about what happens in this particular case. So what should happen? Well, what should happen is the player should be repelled. The player should be repelled to the left. The only question that we have is by how much? How much do we have to repel the player to the left? Well, we know we're shooting out the raycast from the center of the player over to his edge. So this gives us some numbers to work with. If we take right here is that's, again, that'll probably be not visible due to compression. I'm really bad at choosing colors. You can tell I'm not an artist. Okay, so that little green bit right there is going to be where the point is of the raycast. So the raycast is shot out from the middle of the player all the way to his edge, and then it'll hit right there. If we see a hit, we need to repel the player back by this amount. Oh, I just picked up black, didn't I? There we go. By that amount. That's how much we need to shoot the player back. I zoomed in way too much for this example. Let's go ahead and use the power of scaling. Okay, so we're going to shoot the player back that amount. And how do we get that amount when all we have is the width of the player. That green bar right there is the width of the player. We have the player's position, and we have the point in which we got contact. Well, first of all, we need to figure out this value. What is this value? This is going to be the hit point. So we'll say this is the hit subtracted by the position of the player. Hit minus position will give us this green number right here. And then how do we calculate this number right here? Well, we simply subtract the this number, which is hit minus position, by the length or distance of the raycast. And what is the distance of the raycast? Well, the distance of the raycast is half the width of the player controller. So the final bit that we need to repel the character by, so I'll call this offset, is going to equal our width minus the hit position in the x axis minus the position. So the width minus the hit point minus the position will give us the amount that we have to repel the player back. And by repel, I mean go backwards. So if we negate that, we would get the proper algorithm. Sound good?
Darn that mute. Yes, it does.
All right, sweet. So that's basically all we're going to implement. We're going to have it shooting out of the right, and we're going to have it shooting out of the left. The algorithm for shooting it out to the left will be pretty much the same thing as shooting it out from the right. So I'm not going to derive the formula for you guys in this diagram, because I'm much better at using Visual Studio than I'm Photoshop, so I don't want to embarrass myself any further. All right, let's go ahead and jump back into our code. What are we going to do? Well, what we need to do is add in a new method for handling the platforms that can move into it. So we are going to create a new method in this class, and it's going to be located, let's do right after handle platforms. Of course, in your code, it doesn't matter where you add this method. But I'm going to add this method right after handle platforms in our character controller 2D file. So I'm going to say private void, and I'm going to call this correct horizontal placement. It's going to take in a couple different parameters. It's going to take in our ref vector2 delta movement, per usual, and it's going to take in bool is right. The reason I'm taking in is right is that I'm going to invoke this method twice, once for shooting to the right and once for shooting to the left. Okay, so let's go ahead and first get the width. Remember, we need the width, the half width. Let's call this half width. The half width of the player controller. We need the half width in order to calculate the offset that we'll need to move the character by. And that's going to be the box collider's size, his x component of his size, scaled up by our local scales x component, and then divided by 2. It's 2f, just to be a little bit more explicit that we're working with floats. Okay, so that's going to be the half width of the player. Next up, we need our ray origin. Our ray origin is going to be is right. If it's right, then we want raycast bottom right. Otherwise, we want raycast bottom left. All right, so next up, we need to offset our origin by our skin width. And the reason we do that is because as you can see right here in Calculate Ray Origins, these take into account the skin widths. We want to not take that. We want to undo applying the skin width to our ray origin, because we're not shooting out from underneath our skin, we're shooting out from our center to our extents. So that's going to be a different calculation. In order to do that, we have to modify our ray origin by that amount. So I'm going to go ahead and say if is right, then origin.x minus equals width plus skin width, or sorry, half width plus skin width, else ray origin.x plus equals half width minus skin width. So that'll give us those Well, this will do two things. This will, first of all, this will back us up into the center of the player, and it'll apply the skin width. So if you remember, if I flip over to Photoshop real fast, remember that like the bottom right will be this point right here. We need to go back. We need to go back so we're in the center. How do we get the center? Well, we need to take into account the width of the player as well as the skin width, because remember, the bottom right origin is going to be offset by the skin width. So that's what we have to do there. That's what we have to do there. So now our ray origin is in the center of the player, which is exactly what we want. Then I'm going to say var ray direction equals is right vector to right, otherwise negative vector to right. So far pretty straightforward. The next thing I want to do is I want to set the offset to 0f, because I'm going to be collecting an offset from this for loop. And I'm going to say for var I equals 1. It's important that I say I equals 1. Remember, we are only going to be going from the second ray to this second to last ray. We're not going to be doing the top ray or the bottom ray when performing this. Say for var I equals 1, I smaller than total horizontal rays minus 1 I plus plus. Now we're going to have some code that will look incredibly familiar. We're going to say ray vector equals new vector 2 origin dot x. Now we're going to do something weird. We're going to say delta movement dot y plus origin dot y plus I times vertical distance between rays. So we're taking into account the delta movement y. So we're taking into account how much change is going to happen in the y-axis before we do this calculation. And that's important because otherwise, while we're either falling or jumping, these rays won't be inside of the player. They'll be off by basically by 1 frame when being moved, and that's not what we want. We want to make sure that we take into account the delta movement in the y-axis first. Then I'm going to go ahead and say debug draw ray, and I'm going to say ray vector, ray direction times our half width, and then I'm going to say is right question mark color, let's do cyan, otherwise color magenta. So if we're shooting a ray to the right, our debug logout will look cyan, and otherwise it'll look magenta. At this point, I do want to go ahead and jump into Unity and see if our correct horizontal placement is shooting out the proper rays. Again, by doing that first, it gives us the confidence that our rays are being shot out from the correct position. But before I do that, I will have to go in and actually invoke correct horizontal placement. So we have to ask ourselves, where should this method be invoked in our pipeline? Well, we notice right here on line 192 that we are taking advantage, or we are depending on the delta movement y. And if you remember, the delta movement y is going to be modified by the vertical slope method as well as the handle vertical movement method. And that means we need to place our correct horizontal placement invocations after we move vertically. So let's scroll all the way up to our move method and come down here and locate our move vertically invocation, which happens here on line 122. And then we're going to say correct horizontal placement ref delta movement true, and then correct horizontal placement ref delta movement false, because we're shooting to the right, then we're shooting to the left. So again, in our move method, after we move vertically, we'll want to invoke correct horizontal placement for its true value and for its false value.
Alrighty.
All right, so let's go ahead and jump in Unity and see if our rays are being casted. Of course, nothing is going to be different with the behavior, but we want to make sure that we actually have our center calculations set up properly. And if we look at it, we can see that there are cyan and magenta rays being shot out of the player. Now you'll see they do kind of lag behind on the x-axis. We could potentially fix that. I'm not sure how much this would affect our logic here, But if I go into correct horizontal placement, this actual method that we've been working on, instead of saying ray origin.x, I can say delta movement.x plus ray origin. Alright, so that should give us some better looking rays being casted out of our player. They should be more constrained in the x-axis now that we're taking delta movement.x into account. So let's go ahead and fire back up in Unity. Wow, again, with the poorly constructed sentence. And what we can see now is that those rays, those magenta and cyan rays, are now being pretty much perfectly always inside of the player, inside of that box right there. And so that's pretty much exactly what we want to see with our movement. I do notice actually there might actually be a bug, because it looks like while we are indeed in the center, it looks like the skin width isn't properly being taken into account for our right rays. So let's go ahead and fix that. If we're right, we're subtracting by half width plus skin width. Let's go ahead and say half width minus skin width. And let's see what that ends up with. As you can see now, our rays are indeed constrained to the box and no longer have any problems with our skin. Now you'll notice that we still go inside of our platforms, but as you'll see in a moment, we'll get that fixed. So coming back into Unity, we now have our skin width being taken into account properly on our right rays. So let's go ahead and I'm going to remove this debug statement, and the reason I'm going to do that is because it's kind of ugly. I just wanted to do that temporarily to make sure I got the rays right. Maybe even just comment it out. I don't condone commenting out code very often, but this case, leaving that sort of thing commented out is acceptable, simply because we probably won't need it, but if we ever do run into another bug with our correct horizontal placement method, we'll quickly be able to look at exactly what rays are being casted. Okay, so let's go ahead and actually do the raycast hit. So I'm going to say var raycast hit equals physics 2d dot raycast on ray vector, ray direction, half width, and platform mask, just like what we did before. Then I'm going to say if not raycast hit, continue. And then what we're going to do is we're going to say offset equals, are we going right? If we are, offset is going to be equal to raycast hit dot point dot x minus position dot x minus width. Or sorry, transform or underscore transform dot position dot x minus half width. Otherwise, it's going to be width minus transform position x minus raycast hit dot point dot x. And of course, when I say width, I mean our half width. So what we have here is that formula that we're looking at. Actually, I think I got some of the stuff backwards earlier, but now that it's corrected, the formula that most of the formula that we're looking at before in Photoshop, and then the proper formula for handling our left-hand hits as opposed to our right-hand hits. Okay, by the time this loop is done, our offset would be set to something if we're being pushed away by a platform. So now that the offset is set to something, I can say delta movement dot x plus equals offset. And then this will actually perform the pushing of the player to the left or to the right if he's hitting a moving platform. All right, so let's go ahead and open up Unity and see what happened. So now if I come over here and I try to enter this platform, you'll see that I can no longer do so. I now get repelled away from the platform. And the same is true if I'm going to from the right to the left, just as if I'm going to the left, from the left to the right. All right, so I think that pretty much fixes that bug. I do want to try one more thing though. This stuff is a lot harder now that I can't go through platforms.
Imagine that.
Yeah. You will see that if a platform squishes me, I get flung halfway across the map. That is okay. The reason that is okay is you should, as a level designer, you should ensure that you never have a position where a platform can squish a player. Or, if you do want that, most likely you'll have it kill the player. In that case, you could handle that case not by allowing the player to move anymore, but by marking him as dead. Or if you like the behavior of the player being flung halfway across the map if he gets squished by a platform, then of course you can just keep it as it is. Alrighty, so by adding a...
Thanks for that last little bit of letting us designers out.
Alright, so I think that pretty much wraps up our moving platforms. We now handle the actual velocity changes of the platform and how it affects the player's velocity, and we also now ensure that the player cannot be pushed inside of a piece of moving geometry. Now what's interesting about the solution that I've written is just like with the moving platform, it doesn't actually require any additional logic, or it doesn't actually put any additional constraints on the objects that are allowed to push the player. So now any object that has a collider on it will be allowed to push the player, making this a very flexible solution. We don't have to add special scripts to our platforms that can push the player, because all the calculations are done using Unity's basically its collision detection engine, as opposed to implementing it in a different way. So I think that just about wraps up our moving platforms. I guess the next thing that we got to take a look at is finishing our character controller by allowing us to be able to change the parameters of our controller with physics volumes. So yeah, we'll see you guys in the next video.